Well, um, before we get into YY, let's do one more case study with 5M methods, correct? So just watch the video, I will discuss.
There are safe alternatives to the hazardous practices that cause both accidents. I believe they should be used. The accident in ConAgra Food's Slim Jim production plant occurred during the installation and commissioning of a new gas-fired industrial water heater manufactured by Energy Systems Analysts, or ESA. Several days prior to the accident, a new steel gas pipe was connected to a natural gas supply pipe located on the roof of the plant. The newly installed gas pipe ran over 120 feet along the roof and then down into a utility room where the new water heater was located. The new gas piping was pressure tested with air to check for leaks, along with the existing supply pipe. No leaks were found. ConAgra employees then used natural gas to purge or remove air from the supply pipe prior to use. Attaching a temporary hose to the supply pipe, ConAgra workers vented the flammable gas directly outdoors. However, they did not purge the air from the new steel pipe leading to the water heater. On the day of the accident, an ESA worker was attempting to remove air from this new piping prior to lighting the heater. But ConAgra did not always require piping to be purged outdoors. The gas supply valve on the roof was opened. Then the ESA worker opened a valve near the water heater, allowing gases to escape through an opening in the pipe. However, he was unable to light the heater and evidently concluded that this was caused by air remaining in the pipe. So he continued venting the pipe intermittently into the utility room over 2.5 hours. But the air had left the pipe and invisible natural gas began entering the room. No one used combustible gas detectors to monitor the atmosphere. Instead, workers used an unreliable practice. They trusted their sense of smell to warn them of the presence of natural gas. They were unaware that the gas had built up to a dangerous level inside the building. Shortly before 11:30 a.m., the natural gas found one of several potential ignition sources, perhaps an electrical device, and ignited, causing a catastrophic explosion. The building construction included prefabricated concrete roofing slabs known as double T's, weighing about 12 tons each. Many of these double T's came crashing down to the floor more than 20 feet below, injuring and trapping workers.
Monitor the atmosphere for danger.
An ConAgra employee spoke directly to
Of catastrophic incidents.
California that injured 14 workers. New piping was purged indoors.
Similar incident.
The atmosphere for flammable gases.
Natural gas often has an odor added to it, a captain, and this odor is put there so that people can recognize when natural gas is present. However, people don't realize that they can become desensitized to odor.
The CSP also noted that new gas pipes and containers can remove the odorant from natural gas, an effect known as odor fade.
One of the lessons we've learned from ConAgra in these similar
are difficult to completely eliminate. In addition, metal debris expelled from piping can strike other objects, causing sparks that can ignite the gas. More than 150 workers were at the plant that day, including over 50 inside the power generation building. Only about 15 of the 50 were actually involved in conducting the gas flows. Beginning at 7:30 a.m., gas and debris were released from a number of open pipes just outside the power generation building. 15 gas flows took place that day over a 4-hour period. Gas company records show that some 2 million standard cubic feet of natural gas were released to the atmosphere that morning, enough to fuel a typical American home every day for more than 25 years. Around 11:15 a.m., gas was blown through an open pipe into a congested outdoor area next to the power generation building. The natural gas accumulated to dangerous levels, contacted an ignition source, and exploded. Six people were killed, and at least 50 were injured.
The CSB believes that the use of flammable natural gas in gas.
Okay, fine. Are you clear with this? Let's do analysis using 5Ms. Start with materials. What went wrong with materials? What is the gas used? So natural gas. What is the property of the natural gas? What was the activity? Why natural gas was vented? The activity was called as purging. To clean the pipeline or clean the equipment, because it's in construction. From the construction they are just going for pre-commissioning or commissioning activities. So during the construction there may be debris which can be present in the pipeline or the equipment. Before they start the plant, that pipeline has to be cleaned. How to clean? By pressurized, using the compressed gas or pressurized gas, whatever the content inside can be let out. The idea behind is cleaning the pipelines as well as the turbine blades in the second case. So what they done is purging. Fine, it is for cleaning the pipelines. So the material what they used is natural gas, right? Is there any option instead of natural gas? Possible compressed air, but compressed air there may be some issues because which has some moisture. If at all the equipment has to be maintained free from moisture, the option of using compressed air can be ruled out, because generally in air you may find some amount of moisture, or otherwise you have to use the dry air. That is one possibility. Is it possible, can you use nitrogen? Nitrogen is possible to be. What is the property of nitrogen? It is an inert gas. If assume that if they would have used nitrogen, what will happen? It is an inert gas. It may not form a explosive vapor or flammable vapor, right? It is very well we can eliminate this incident by using nitrogen or say air, possible. So here the problem is with the material. The reason behind is they used natural gas for purging, that is the content based on materials, correct? How about the man? Next M. What are the problems associated with the man? Welding was going on nearby. So what is it is a method or man issue? Take an example of first one. Okay, second one there is no much of man involvement. You are not seeing any man, right? The second one. But see the first case. You seen people who are literally there to drain. He is seeing that there is no ignition starting inside, because there are lot of air trapped inside or natural gas trapped inside which has to be vented out. He tried a lot for 2.5 hours as per the discussion. So other person also came. he believe in his sense for seeing that whether there is a gas present in the room. Is it the right way to do that? Right, the man is, he has not conducted any gas test. He was present in the room, he was doing the purging inside the room. Outside, the second case is very different, which was vented outside the building. The first case was vented inside the building, which is always confined. Inside the room means what? Outside is it can be dispersed, but inside the room it is always possible the vapor can remains there. Wherever it gets ignition source, there is a possibility, right. The operator was venting inside the room and he believes in his sense. That is problem with the man, right. Next method, again it is purging inside or outside, it is again a method. The first case, if you take it, he should have went purged outside, he would have extended the line and let out the gas outside the room, then there is a possibility it would have been dispersed and there may not be possibility of vapor cloud to present, right. Or otherwise method, whether that room is provided with all HAC, hazardous area classification equipment, electrical fittings were flame proof. There was a gas out. So, where is the ignition source come from? Probably some of the electrical equipments would have given a chance for ignition. So, it forms as a ignition source, whether that room was selected. So, all these things comes under method. So, HAC, hazardous area classification, whether it was considered, whether it was done. You understand what I am trying to say? So, taking 5 M's, using each case you can put yourself questions. What went wrong with man? What went wrong with method? What went wrong with material, machines and management? So, how all these activities are controlled? Do they have any permit procedures? Do they have any supervision? Do they have any proper procedures? So, all these things comes under management. Are you clear? So, how to approach an investigation? Clear or not? Do you have any questions? Okay, let us go with to next method, which is a 5 why methods. Okay, this is one of the typical sheets, company to company, people to people use different spreadsheet for capturing the YY analysis. This is one of the way to capture. The defect description is given in the top. What is that? A welder was assigned with the preparation of the transport oil glass cover. While punching the glass to make a hole, the hammer slipped and hit his left hand thumb finger close to the nail. He was wearing a leather gloves while doing activity which reduced the impact of the injury. It is a very simple straightforward case. What has happened is, there was a piece, the person was holding a punch in one hand and using a hammer he is hitting. Hammer and a punch. When he was hitting, he hit his finger, thumb finger. So, why it has happened? Why it has happened? Occurrence factor. Why this incident happened? Hammer missed the punch and hit the thumb finger, correct? Instead of hitting on the punch top, there is a head, right, for the punch. Instead of hitting in the head, it slipped. You people went to Smithy and all no laboratories. So, probably when he, instead of hitting the punch, he hit his finger. It slipped or missed and hit his finger. Okay, next question is, why hammer hit? Hammer was not suitable for the job and not checked by the supervisor, and punch head was small to be held by the hand. Punch was too small, and when he hold, there is always, hammer head was very big, punch head was very small. What will happen? It can happen. Why the punch held in the hand? No other method. There would be any some other tools to hold the punch. If at all he used like, what I can say, like a clip or something. So, probably he would not hit his finger. So there was no other method to hold the punch. So why it was not insisted? Because supervisor has not advised the person. It's a lack of supervision. It's a simple case. It's resulted in a injury to a person. The same thing you can apply for anything. Here you see that finally the conclusion is there is one more thing, causes investigation. Check the required tools, create the method for the activity, no holding tools available. So the root cause comes like lack of supervision and no methods. So similar way you can put YY question to any numbers and you can try to get the answer.
Describe a funny feeling where they can take a deep breath and they still feel like they're suffocating.
On November 5th, 2005, 2 workers died at Valero Energy Corporation refinery in Delaware City, Delaware. They had entered a reactor vessel, a confined space that was filled with nitrogen, an odorless, invisible gas. The accident occurred during a maintenance operation at the 5,000-acre facility, which processes 180,000 barrels of crude oil per day. The complex is one of Valero's 18 U.S. refineries and has 570 employees. The U.S. Chemical Safety Board investigated the accident and issued a case study with safety recommendations.
This is not a new issue for the CSB. In fact, the board conducted a earlier investigation into the concepts of nitrogen asphyxiation and issued a safety rule in 2003. Rule identified 85 nitrogen asphyxiation incidents that occurred between 1992 and 2000, killing 80 people and injuring 50. That study and incidents since its position in 2003 show that lives continue to be lost because workers are not being made aware of the dangers of oxygen deprivation.
Oxygen comprises 21% of the air we breathe, and humans cannot survive for long when it drops below about 19%. In refineries and chemical plants, dangerous, low-oxygen environments are created when dark gases like nitrogen are used to remove oxygen from pipes and equipment.
The risk of oxygen in the private atmosphere is that you will get trapped in that situation, get trapped and die.
Dr. T. Gaddafi is a physician and chairs the Department of Environmental and Occupational Health at George Washington University. He describes the effects of oxygen deprivation on workers.
When a moment a person first goes in with oxygen in the private atmosphere, they are effectively in air. And when the oxygen deprived atmosphere begins to enter the lungs, the oxygen in the blood, so the brain starts to fall. That affects the brain's judgment, it affects the breathing, it affects the ability to exert strength. They fall down, fall unconscious, or their judgment is so impaired that they can't find their way back out, and they die.
CSP case study on the Valero accident underscores the importance of strict safeguards when working around low oxygen environments. Workers are in danger not only inside confined spaces, but also around openings where inert gases like nitrogen are flowing out. Here's what we believe happened the night of the accident. Valero's hydrocracker reactor number R1 was shut down for maintenance. A large pipe elbow had been removed, creating an opening surrounded by large steel holes in the middle of the platform. Workers had wrapped red tape around the holes and covered the opening with plywood and plastic. Nitrogen flowed into the reactor and exited from the covered opening. Nitrogen is invisible, but it is colored light green here for illustration. Workers had attached a sign reading, "Danger, confined space, do not enter without permit." However, there were no specific warnings posted about the nitrogen hazard. A crew of Matrix contract workers had received a Valero-issued permit to reinstall the pipe elbow. The safe work permit did not warn the crew that the reactor was filled with nitrogen. In fact, the permit stated, quote, "Nitrogen purge NA, not applicable." 2 contract workers removed the plywood cover and cleaned the ledge around the opening. At about that time, a third worker noticed a roll of duct tape lying 5 feet down inside the reactor. then got closer by sitting on the ledge of the opening with his legs dangling inside, but he still could not remove the tape. Based on the evidence, the CSB developed two possible scenarios for what happened next. In the first scenario, the worker lowered himself into the reactor to quickly grab the tape, relying on his foreman nearby to insert a ladder so he could climb back out. But after lowering himself into the reactor, he inhaled the nearly pure nitrogen inside. Deprived of oxygen, he quickly collapsed. In the second scenario, the worker on the ledge leaned over the opening, trying to get closer to the tape. At that point, he either accidentally slipped into the reactor, or he breathed in the oxygen-deficient atmosphere just above the opening, lost consciousness, and slid in. What happened next added to the tragedy. An eyewitness saw the foreman and the contract administrator peering into the reactor. The stricken worker was lying unconscious inside. The foreman quickly inserted the ladder into the reactor and climbed down to help his fellow worker. But without a breathing apparatus, he too collapsed from the lack of oxygen. The contract administrator declared an emergency on his radio. Bolero operators then sounded the unit alarm. When company emergency responders arrived a short time later, they saw both victims lying motionless inside the reactor. A handheld meter inserted through the opening showed less than 1% oxygen, a lethal atmosphere. Wearing supplied air breathing equipment, the responders entered the reactor. A rescue hoist was used to remove the workers. It was now almost 10 minutes since the first worker had collapsed. Attempts to revive the men were unsuccessful, and both were later pronounced dead in the hospital. The CSB believes that two workers died within a few minutes of entering the nitrogen-filled reactor. This tragic accident was avoidable. The CSB determined
Okay, well, for this particular accident, which will be the most suitable method to analyze? Which one will you select? We have seen different models, right? Different methods to investigate. Fault tree, then comes 5M, then 5 Ys. Which will be the most convenient, suitable method to investigate this particular accident? If you are an investigator, which methodology will you take? Will you adapt to investigate this accident? You can apply any tools, agreed. Okay, if you are there as an investigator, which will be the most convenient method to investigate this particular accident? 5M? Okay. 5Y also? Good. Okay, let's try with both, not a problem. Okay, majority will go with 5M. We will start with 5M. Start with man. What went wrong with the man? What went wrong?
Oxygen level.
Pardon?
They didn't check the oxygen level. Nitrogen level.
The work permit.
What went wrong with man? Man, material, method, machine and management, right? We start with man. What was the mistake committed by the person? Okay. Something dropped inside. Right? Let's understand that scenario. Two persons were asked to do work externally, not internally. In the sense, not enter inside the tank. The work was, there is a reactor, and reactor top, that spool piece, that a pipe piece, right, that has to be connected. So they were asked to do some preparation activity for connecting the pipe, not to enter inside. Okay, something dropped inside. Okay, if something dropped, what they thought, if supervisor or superior comes, he will scold him or something. So without informing him, he wanted to take out the piece, right? So during the course of action, he could not able to achieve it, so he entered inside. Here the problem with the person is unauthorized entry.
But it's not like they show the two cases. Now he might have entered.
Okay, there are two things. In the both the cases also I will say. One person intentionally get in to take it out. Second one is he sit during the course of when he tries, probably he is suffocated and fallen. But entering inside itself wrong. One is fully you entered. Second case is halfway you entered. Means that your legs are inside. Your heads are not inside, your legs are inside. You try to enter in only. So both the case you are not authorized to do any activity inside it. If you see in the permit, what was mentioned? Nitrogen? No, it's nothing to talk about confined space entry. They were not authorized to enter. So that atmosphere is safe as per them. So people here the problem is, first one is unauthorized entry. Second thing is, do they have any knowledge about what is inside? Because there was a label. These people were, whether they were aware about nitrogen. If he knows, probably would have not done it. It's a lack of knowledge about the working conditions. Correct? In addition to that, if you have seen, there was other person who was standing in the top and monitor these people. He is not connected with the job or not. He was a supervisor, whereas he didn't stop them. Lack of control, lack of supervision. Such a critical activities, someone has to be a senior person or a superior, supervisor has to be there to control this sort of activities, which was not happened. The job was not properly explained. Probably when you would have given a caution to the person. Here there is a clear negligence of supervision. All these things we can bring it in the head of man. Correct? Next comes machine. What are the problems with the machine? In the machine, in the sense, it's equipment, I would say. What are the problems? It's open. If it is closed,
There was no label.
Okay.
No label citing that the atmosphere has nitrogen inside.
okay, inside is pressurized. So naturally, because of the pressure difference, you can see something outside also, because it's shown as a pressurized system. Okay, the machine, one thing is it was kept open, point is right, intentionally someone can go inside. The intentional allowing inside the person could have been stopped by closing it, but the purpose here is venting. If at all you close, how do you vent it? Understand? But there is other way to look into it. Instead of fully covered with the manhole, probably you would have some sort of venting mechanism, some sort of meshes, with the mesh type something you would have been closed. There is a possibility. Yes, it was not properly closed. The labeling was proper. Label was sufficient enough to caution the people. There was some barricade, but it was not a hard barricade. Probably the entire area, if you would have barricaded, restricting the people to enter, it's a soft barricades, like a tape, right? It's not a hard barricade at all, in the sense which is not so sturdy and visible to stop people to enter. That should have been there, correct? Okay, coming to the method. What is the problem with the method? Method. Nothing to comment in this case, correct? Material. Why it was dropped? What is the piece which was dropped inside? Something like that, some small tape or something which was dropped. Where is stored that operator? Is there any toolbox? How do you just interpret? You understand? Here it's a tool, but why this tool fallen inside? Because it was not properly stored by the operator. He was not using proper toolbox. If you carry something, what will happen? It bounds to happen. It may fall, correct? So there was no proper toolbox he used to store materials. That was the root cause, to be very frank. If it was not fallen, why you would have tried? Correct. That is one thing. In all these things here, it is very clear, there is a lack of supervision, lack of procedures or lack of knowledge. This all these things comes under 5M, that is management. Are you clear with this? Clear. So, that is one way of approaching this. What is the next method we told about this? 5I. Just apply 5Is for this. Why there was a fatality?
Lack of oxygen content.
Nitrogen was inhaled and there was acid.
Okay, good. That is the way we can proceed. So, it gives your lack of this thing, it's closed ended, but her answer is open ended. You understand what is the thing? So, what she told?
Nitrogen was present in the nitrogen was in the atmosphere and they inhaled it and they got suffocated.
Okay, why they inhaled the nitrogen?
Right in a confined room.
Because they entered into the confined space. Why they entered into the confined space?
It was
That is one cause. So, you understand how you have to take. If at all you just put the close question like yes or no question, then you cannot able to lead the discussion where it will be closed there. So, you cannot able to go further till the root cause. So, always you need to, whenever you question as an investigator, you have to raise open ended question. As well as when you develop a tree, develop some sort of logics, then you need to always identify the open loop questions so that it can be extended further. After certain times you cannot further open, so it will be closed at one end, but as far as from starting you need to always give open ended answers so that you can able to lead the discussion till you reach the final root cause. You people are clear with this? Okay, this is event tree analysis. This is a complementary technique to FTA, but defines the consequential events which flow from the primary initiating event. Fault tree analysis is a reverse thinking technique, in the sense from the event or from the fifth domino we go back, but whereas event tree is a forward thinking. If at all there is a valve failure, assume that there is a near miss. In this case it was a near miss, but you are so keen in investigating a near miss, so you can just use the fault tree techniques so that you can understand what extent this near miss or this event can result in, that you can able to establish using a event tree. So, event trees are used to investigate the consequence of loss making events in order to find ways to mitigating rather than preventing losses. It is again a proactive forward thinking method. Here it will be always you can use event tree to investigate your near misses. So, as we say like Frankfurt or Henrich, 330 cases out of, for every 300 near misses there would be 129 minor incidents, and 329 cases there will be one major. This is about Henrich. When you talk about Frankfurt, it is 600, then comes how much? 600, 40, 641, correct? 630, then 10, then it is 1. So, 600 are near misses. Using the event tree, you can able to trace the path, you can apply some control measures so that the major serious or disabling injury or incident can be prevented. So, event tree is generally a proactive method which can be also useful for a investigator to do. How to go about the event tree? Identify the primary event or concerns, take near miss. Identify the controls that are assigned to deal with the primary event, such as automatic safety systems, alarms and operator actions. What are the control measures which supposed to be there? Just assume. Construct the event tree beginning with the initiating event and proceeding through failures of the safety functions. Establish the resulting accident sequences. Probably it will be end up in explosion or a fire or some sort of loss. So, identify the critical failures that needs to be addressed. So, out of these three what you establish, identify the critical things where you can just impose some actions so that the final event can be prevented. So, all these methodologies we use are mainly to identify the root causes or the basic causes. So, the purpose of identifying the base causes is to really look into it and suggest some control measures or suggest some recommendations. So, when you develop an effective recommendation, what you need to do? You need to be very specific in it. You do not give generalized recommendations. The most important final step is to come up with a set of well considered recommendations designed to prevent recurrence of similar accidents. Once you are knowledgeable about the work process involved and the overall situation in your organization, it should not be too difficult to come up with realistic recommendations. Recommendations should be specific, constructive, get a root cause, identifying contributing factors. Generally, recommendations should go in that way, like corrective actions, corrections, corrective actions and preventive actions. Corrections are something immediately you do to bring the situation back. Corrective actions are something you implement to avoid an accident. Preventive actions are which really you similar things wherever it is a ahead thinking in order to similar things wherever possible in your areas that has to be prevented. So, your recommendations generally gives in these three categories like corrections, corrective actions and preventive actions. So, that is it. Any questions? Any questions? So, in the last 2 days we started with the accident causation model to summarize. So, accident causation models we started with the dominoes effect using Henrich model, and there are different theories we look into it, epidemiology theories, systematic theories and multiple causation theories and all. Then finally we end up with Frank Bird models, which given a different dimension from Henrich, say in the sense fifth domino, instead of injury he slightly changed the word injury into loss, like. So, in addition to that lack of control, the management control also demonstrated in the Frank Bird's theory. So, after that we started with the different case studies using different methods, we could do that. So, that is it. Any questions? Okay, if there is no questions, let us break. Thank you. Okay, good evening. Yesterday we have seen various accident causation models starting from domino effects, which first theory which was developed by Henrich in 1931, then how the transformation happened, and the new dimension given by Frank Bird in 1980s. So, yesterday we seen that. So, in addition to that, yesterday we seen and we discussed on how to form the investigation team and what are the do's and don'ts when you perform investigations, right. To summarize that, so investigation team should be comprised with different expertise. In general, they should not be a part of the team, part of the department or part of the area where the accidents happen. They should be an independent, the people who can provide independent view as well as who has good knowledge about the processes or the work nature or this thing. So, in addition to that, the team has to gather information, they have to secure the scene, they have to take statement from the witness, victim. In general, the statement has to be taken separately, not as a group. Then later on they can just summarize and conclude the results. So, idea began doing the accident investigation to find the facts behind the accident, so that you can just narrow down the causes to go up to the root causes, and you can suggest some control measures so that you can avoid accidents in the future. Okay, well. So, before I go to the different methodologies for doing the investigation like FTA, fault tree analysis, 5M methods, fishbones and all this thing, before I start with the basic understanding, the different studies what we studied yesterday, using that we will try to investigate one accident. So, the accident which I am going to show is generally familiar, you people are aware about Bhopal gas tragedy. one of the worst disaster in the history of industrialization, which happened in 1986. Okay, you've seen the results of that. So here is a schematic diagram of what went wrong. So there were 3 tanks, right? The horizontal tanks, number say E610, E611 and E619, where the methyl isocyanate was stored, right? The case is that accidentally water entered into the tank number 610, which has, at the time of accident there were 40 tons of methyl isocyanate stored inside. Because of the water entry, there was a rapid reaction and the gas released, which resulted in the devastation. Okay. Yesterday we seen 2 theories, right? The first one, what we seen is the model of Henrich. The second one in 1986, which was developed by Frank Bird. Okay. Using that model, let's, for each domino, we will identify the situations. What is the 5th one in Frank Bird?
Try and find losses, total losses.
Its losses, right? When it's Henrich, he told that the 5th domino is a injury, but whereas in 1986 the new dimension was given, not only accidents result in injury, not necessary it should be result only in the injury, it can be a loss, it can be a property damage, it can be material damage, downtime or anything. So Frank Bird theories remains now, as well as the process safety movements get activated after Frank Bird's. So here the last one, the loss is fatality, right? Death of people, 2500 official figures, right? So what's the, why it happened? What is the preceding domino? Release of methyl isocyanate, correct? What is the preceding domino? Unsafe act and unsafe conditions, correct? What is the unsafe act and what is unsafe condition? Release of methyl isocyanate to the atmosphere is an accident or an event. It resulted due to the conditions as well as act. What are the unsafe acts and what are the unsafe conditions? Accidentally water entered inside the storage tank. It is by unsafe act of a person who connected the hose. He has not done any pre-check. So that is called as unsafe act. What are the conditions? What are the conditions? Okay, park it. What is the preceding dominoes again? Basic causes, correct? What are the basic causes? Again, basic causes can be divided into 2. One is personal factor and second one is a job factor. Personal factor, when you consider lack of knowledge of the individual who connected the hose. So what is about the second part? Job factor. What are the job factor? From this schematic diagram, what you could able to find it here? This is the tank from where rapid reaction happened, and because of the rise in temperature, the valve opened and just went into the atmosphere. What is this? It is a refrigeration system which was meant for maintaining the temperature inside the tank, but the condition was the Freon system to cool liquid MIC was shut down in June 1984 to save money, and from Freon shipped to other plants, means that refrigeration system was not in operation, correct? So this are all comes under job factor conditions. Okay. Then what is this one? Vent gas scrubber. If at all there is a release from the tank, it has to go to the scrubber. In the scrubber, where it will be neutralized and it will be let out as a, not as a toxic mixture. But what is the condition of the vent gas scrubber? Leaking gas could have been detoxified, means that because of the neutralizing agent it would have been detoxified, but it was not in the working conditions, right? It was also in the turned off condition. There is a other safety feature which is called as flare tower. What is the purpose of flat cover? If at all there is a release of a gas, it is burnt and let out a smoke or sort of things. It will not let out toxic gas. What is the condition of that? Designed to burn off the gas, but a connecting pipe had been removed for maintenance. There is no continuity, the integrity of the system was defeated. So again it comes under conditions, right. All these unsafe basic causes are the result of lack of management control. There was no management control, there is no inspections, there is no mechanical integrity being ensured in the company, correct. There is no systems like work permit systems to ensure it, there is no management of change. Refrigeration system was intentionally removed by the management, but it was not recorded as a management of change. No PHA was done. If there is no scrubber, then what will be the result? So in addition to that, as a passive protection, there is a water curtain. What is the purpose of water curtain? If at all the gas is released, it should not be dispersed. If there is a water, so what will happen? It can be contained. In addition to that, methyl isocyanate with the water, it may not be that much toxic, it can be contained. So that is the reason there is a water curtain also, which was also not high to contain all the gases which is released from the vent gas scrubber. So all these reasons, all these factors, complex factors led to an accident. Could you get my point? So it is a way we need to come back, take a dominoes, we start from the fifth domino, that is a result, which is generally a loss. Loss we consider as a, what happened is a fatality, then it is an accident, release of methyl isocyanate to the atmosphere, then it comes to the, we are trying to identify and say facts and condition, then basic causes, then it comes with the lack of control. Could you able to correlate how do you apply the same theory in the proactive sense to identify the root causes for the incident? Clear? Okay. Refrigeration system was not working. What is the PSM element missing over here? There was no process hazard analysis and management of change, correct? There is no work permit system or training, no process hazard analysis, because vent gas scrubber was not in line. But what will be the effect? Nobody has studied, nobody has critically examined to understand the risk. There was no operating procedure. If at all there is no scrubber in line, so there should not be operation, so that is not listed over here. Then there is no flare, there is a pipe which connected with the flare was disconnected, mechanical integrity was not ensured, correct?
So flare is basically to burn the chemical.
Yeah, flare is something like a chimney. So when the gas let out, so basically it will be burnt out. The toxic gas which go through the flare will be burnt out and only it will go as a smoke or whatever it is. Means that the toxic effects will be suppressed over there. Okay, oil and gas industry also there is a flare. Excess oil or gas which will not be let out, so which will be burnt and only the smoke will be going out. So that is the purpose of flare. So even it is flare, if you see that designed to burn off gas, designed to burn off the gas, excess gas, that is the purpose of flare. Okay, emergency planning and response, which is a part of the curtain, which is also not active or not in the line. So all these different factors which result in a major disaster. Could you get it? As we said yesterday, for every accident there won't be a single cause, it is a multiple cause which is generally interactive, which leads to an accident. Okay. This is one of the techniques which can be used for investigating an accident, which is generally called as fault tree analysis. Probably you would have seen in different, it can be applicable in different places. Here we take fault tree analysis for investigating an accident. So what? A structured team analysis of the possible underlying causes of a known equipment failure. Take an equipment failure, it is a reverse thinking technique. We will start with the end result or end event. From there we just try to develop a tree, go back, until you reaches the basic cause, means that where you cannot able to develop a tree, we stop it there. So all the unconcluding basic causes can be result of an incident. We try to correlate or set points so that we can able to identify all the root causes in it. When root cause analysis of failure is needed, why? A better understanding of the root causes of a failure, a better set of action plans to eliminate those root causes. When you just brought down the root causes, when you just go till the end, means that where you cannot able to further develop, so that we generally called as basic causes or root causes. For each and every root causes you will find a solution, so that you can able to, if the solutions are implemented, you can able to prevent an accident. So these are the symbols generally used in the fault tree. The first symbol squares describe a failure or an event, correct. It can be a short event or an intermediate event also. We will use a square or a small rectangle. So OR gate is a either or situation. There may be 2-3 causes, not necessary together it will result in a event, either one will be resulting in an event. So AND gate, it is a combination of 2 or 3, when all together these causes happen, then it result in an event. Then circle is for the basic event, whereas further we cannot able to extend it. So diamond is potential failure which is not analyzed for various reasons. The decision making gate. So how to go about fault tree analysis? First identify a top failure. Take an example of a Bhopal gas tragedy where we discussed. So what is the top event? Fatality, death of people, that will be the top event. Then brainstorm basic contributors to failure. From there you will derive a tree using different gates. It can be AND gate or OR gate. Whenever you choose OR gate, it is independent, the causes are independent, but when you take an AND gate, it is a combination of 2 or 3 causes. So link contributors to the top failures. So you derive a tree, determine which combination of contributor is needed to cause the top failure. So it is basically a brainstorming session with the people. So using this tree, using the logic gates, you try to develop trees until you derive a basic causes. Okay, this is the structure of the tree. Let us take one example and we will work out on it. Could you able to identify what activity the person is doing? It is a grinding operation. You are aware about grinding? So grinding can be done by bench grinder or an angle grinder. What is the difference between bench grinder and angle grinder? There is a bench grinder, right, which will be fixed in the table or something like that. So where the wheel revolves, whereas you hold the tool to grind it. So in bench grinder, an operator controls the wheel or a tool or workpiece, sorry. There are two things, wheel is rotating, grinding wheel is rotating, and operator holds the job. Take and assume that it is a knife where you wanted to sharpening the knife. So the operator holds the knife against the rotation of the wheel. Here operator is controlling the job, not the wheel. Wheel only just you switch on, wheel starts rotating. When you switch off, wheel stops. The operator controls only in the job. In case of angle grinder, operator holds the grinding machine in his hand, correct. The job is generally, job should be fixed. So this, for example, take an example, the job is here. So operator holds the grinding machine and he grinds the job. Here the job is fixed, operator controls the machine. So that is the activity. What happened in that? Fatal injury to the operator. Can you imagine? It was a live case, recently we investigated. Okay, the cause is something like that, the grinding wheel broken and hit the operator's scalp. So he was taken to the hospital. After 10 days he was declared dead. Okay, what are the reasons behind that? Let us just go by the fault tree analysis. The top one is what? Event is fatal head injury due to the breakage of wheel. The wheel broken and wheel hit the person's scalp. Okay, do you know that what is the speed of the wheel? Generally the wheel speed is defined in RPM. It is generally the speed varies from 6000 to 9000 RPM. In the sense per minute it revolves 6000 times. Imagine the speed. Based on the speed you can assume that what will be the force. So even a wheel breakage which hits the head and resulted in a fatality. So assume that what is the force in it. Okay. How it has happened? Why it has happened? It has happened due to the grinding wheel breakage, correct? Grinding wheel breakage is the only reason. What is the next one it is given here? Ineffective machine guard. What is machine guard?
In case wheel comes out, then
It's like a cover for the wheel.
Exactly, it is a cover which was provided over the wheel. Generally the machine guard has to be provided in between the wheel and the job. Idea behind it, operator controls the machine, wheel is rotating, the guard is generally provided in between the operator and the job. If at all there is a breakage, it should not come towards the operator. You understand what is the idea behind it? Because if you cannot provide a full guard, if you provide a full guard you cannot work, so workability will be missing over there. So yes, partial guard, in the sense guard shall be provided for 180 degree of the wheel, half of the wheel has to be covered and wheel guard position has to be in between the operator and the job, correct? If at all the guard was proper, whether it would have reached the operator head. So it is a clear case, there is a problem with the guard. So that is the reason we put two events. One is grinding wheel broken, not only the reason, grinding wheel broken and it just flew towards the operator due to inadequate guard. So that is also the reason. If both the events together happen, then only it is a result of and fatality. You understand? So it's here we used AND gate. Okay, leaving that guard part, we can analyze later. Why the grinding wheel broke? It can be due to overloading or improper mounting of wheels in the machine, or otherwise machine speed very high. Second one is improper grinding operation. In every wheel is defined for maximum speed, it is called as RPM. So means that the wheel should not be operated more than that particular speed, correct? If at all assume that wheel fixed in the machine was rotating at high speed, wheel will also rotate, no? Wheel is rotated due to the rotation of the machine. If at all you are not chosen a right machine, wheel is designed for 6000 RPM, whereas the machine was rotating at 9000 RPM, wheel will also tends to rotate at 9000 RPM. So naturally the wheel can break at the point. So there can be one cause, machine speed very high. Second one is overloading, what we discussed, how the wheel was mounted in the machine. It can be over tightened or it can be loosened. Both the reason it can fail. Next one is improper grinding operation. Probably the operator would have been forcibly apply the wheel over the job. That is also cause. If you apply more pressure, more force, wheel tends to fail. So all these things can be possible, but it is not together. Any one event can result in a successive event, correct? That breakage of wheel. Could you follow me? Then go overloading of or mounting of wheels. What would be the reason? Non-availability of the tool. Probably he may not have a right spanner, so he has not properly tightened properly, or probably assume that he has to use a torque wrench. What is the advantage of using a torque wrench? You know that how much you are tightening. When you tighten the spanner, by assumption you tighten, but when you apply a torque wrench, you know that what is the torque you need to set for the particular bolts. So non-availability of the tools. Then lack of procedure to define the standard mounting. how to fix the wheel. So, probably there may be lack of procedures. Lack of operator control means that operator was not supervised. So, any one of the reason can lead to a overloading of wheels. Then machine speed very high, machine speed more than the wheel speed. Possible? That is a possible. So, that is a direct basic cause. Further, the tree was not developed. Could you get it now? Because machine speed, if at all machine speed was more, nothing can be done. So, that is a direct root cause. So, that is considered as a concluded as a B1 basic cause. The round one is a basic cause. You cannot further develop. That's one of, that cause itself can result in an accident. Then goes to improper grinding operation. Why? Unskilled operator. Whether the grinder has sufficient competency, skills, training, that would be the reason. Poor operations, pre-operation checks not done. Probably the wheel would have been broken before itself. He has to check the wheel before he mounts. Probably he was not done. Operator not attentive, maybe due to some psychological issues or some problems. Urgency in completion of the job. Probably the operator was in some urgency, he wanted to complete the job well in time. So, all these things can be lead to improper grinding operation. Okay. Here the lack of procedure also comes directly as a basic cause. Then non availability of the tool. The reason behind it is lack of control of tools or damaged tools. So, probably the operator may not have a right tools. The supervisor did not give right tool to the operator, that may be one of the cause. Or second one is damaged tool, he may not have a damaged tool, so he taken some tools as a jugaad for working in it. So, all these things can be a cause leads to procedures. You understand how its cause to be derived? Any questions? Okay. We establish a tree, we develop a tree till you reach basic cause. So, whatever which comes in the round B1, B2, B3, B4, B5, all these things are what? Basic cause or root cause. So, you need to focus how to prevent these basic cause. For each basic cause, you need to provide a suggestions or the recommendations. If these recommendations are addressed or implemented, then these accidents can be prevented. You understand how to go about it? There are different ways to go perform an investigation, generally by checklist, by investigation, by interrogating with the witness, by taking a statement, by physically check the working place, verify the documents, you can able to conclude. Certain things, if you are not in the position to conclude, you can take some methodologies. One of the investigation methodology can be fault tree. So, the way you have to proceed is this. Any doubts? Shall I move on? This is the next method, 5M methods. Yesterday we discussed about it. What is 5Ms? Man, machine, material, method, management or mother nature. It is an environment factor also you can consider. The 5M methods comprises of man, machine, material, method and management. There are 5 core areas that following factors of accident and incident may appear in. When you consider a man, it refers to human elements inclusive of psychological, physiological, proficiency aspects, skill aspects as well as qualification of performing the task. Okay, personal factors. We all talk about basic causes. In basic causes there are 2 things, one is personal factor, second one is a job factor. Here the man we address the basic cause of personal factor. Then machine, job factor, refers to equipment such as machinery, computers, tools, instruments. Material refers to defective material or incompatibility material properties. Methods refer to the rules, regulation, laws or standards or procedures what supposed to be followed. Management refers to supervisory capacity of management in terms of regulations, policy, attitudes towards safety. So, generally the 5M methods, Ishikawa diagram, we generally try to put questions, causes, try to identify in relation with 5Ms and we try to conclude as a basic cause on that. Okay, this is an simple case study to explain you. From the figure you could understand what is that. It's a EOT crane, electric overhead travelling crane. You people have seen EOT? Okay. In industries or workshops, to transfer material from one place to other, generally there will be a crane. The crane will be moving in the rails which is in the top. There will be two rails, in between that there is a trolley fixed. So you can able to achieve long traverse, means that the crane moves from one end of the building to other end of the building in the wall. In the sense, in the rail it moves. Horizontally also you can just move the trolley, because you may have equipment in different places, so it has to move horizontally as well as longitudinal. So there will be a hoist in the top, like a pulley block, or which used to the hoist from top to bottom and bottom to top to pick up. Here what happened, in the crane movement is generally controlled by pendant switch operated by the operator from the ground. EOT cranes can be operated by two ways, which can be operated using the pendant switch, which can be kept by the operator from the ground, or sometimes operator sits in the top of the EOT crane. There will be a cabin and he can operate. Sorry. For small cranes, generally operator use the pendant switch to move. An operator was shifting an empty tank from the welding area to the dispatching area by using the EOT crane. The EOT crane could not be stopped during its travel due to the failure of the pendant switch buttons. If you see the pendant switch, there are two buttons. Two buttons in the sense, one for controlling the long traverse, means that from this wall to that wall the crane has to move, right? That has to be controlled. So there will be a two switch. In this direction also you can just take the crane, or in the reverse direction also you can take the crane. Then there is another movement which is to horizontally move the cabin. The next movement will be hoist movement, up and down. The pulley will be there, which will be lifting to the top to the bottom. What happened, that operator lifted the tank. Then he started moving from one end of the wall to, assume that one end of the wall to other end of the wall. So in between that there was some cabins. You seen the first photo, right? This photo. You seen it? This is a long workshop area. In this there is one room which is in the corner of the floor. So what happened, when he was moving the crane, there was some problem with the pendant switch. He could not able to stop the pendant switch. The movement could not be controlled. So the crane directly went and hit the office area. It was a glass and false roof and all these things. It was the tank which he was moving. So he could not able to control and hit the office, and it damaged. Assume that there are some people. Okay. Immediately the operator switch off the main power. What happened? The operator immediately ran and switch off the, not from the pendant switch, from the main switch, and stopped the operation. This was the thing happened. Shall we just work out on the 5M methods for this? You could able to understand what happened exactly, right? Where from we will start? From the machine. What went wrong with the machine? There was no control. Loss of control. The basic cause behind the loss of control is EOT crane was under maintenance. It was under repair, but person operated the machine. So it was under repair. So that was the straightforward case with the machine. The repair amidst the faulty machine was used. That was the major cause. Then go to the men. Operator is not experienced and trained. The crane operator who used it was not trained. Operator is not authorized. First of all, he is not trained. Only trained person for controlling the cranes. This sort of activities are critical operations, because he is lifting 5 tons, 6 tons of load from one place to other. There are so many machines below. when he is taking the machine, if at all the sling is not proper, if it falls, it can fall on the machine, it can fall on the people. There may be some 20-50 people working in the area, whereas the equipments are being handled in the top by using the crane. So it needs to be operated by a trained person, authorized person. In this case, he was not trained, he was not authorized. Health condition of the operator is generally good. Then comes to the material. Same problem occurred regularly. Failure of controls used to happen regularly. Yesterday we seen one violation. What is that? Routine violation or situation violation. You remember what are the things, how to correlate with the causation models. So it is a routine thing. That is the thing they are saying. Same problem occurred regularly. Next, all limit switches are in working conditions. In addition to that, the crane has inbuilt safety features called limit switches. There was a rail I told in the top. If at all the hoist moving and go and hit the rail, what will happen? It should not go till the end, because if it goes, it can fall. There is a limit safety features called limit switch. Means that when it goes to the end, it used to stop before 1 meter of the end. The similar way there is a feature, but limit switch was here working. Push buttons, movement controls are not properly working. The controls what he had in the hand was not properly working. Same problem occurred earlier. Then what is the method issue? During maintenance, emergency stopper was bypassed, because as we say that there are limit switches, correct, which was bypassed because because it is under maintenance. So that is why it was not working. So near miss occurred and damaged the cabin, that was the cause. You understand how to go about it? Man, method, material, machine. Here one more thing is there, management. Management, because that has to be also taken. Management again comes, there is no supervision, there is no control over the operator, there is no work permit system, correct, because it is under maintenance. There should be some tag, there should be some lotto, lockout, tag out, the control panel should have been locked so that other operator cannot operate. All these things comes under management. Okay, what are the root causes here? Root causes, green are root causes, red is not valid, yellow is valid, means that it is a likely cause, green are likely cause, yellow are qualifying cause, and red are ruled out. In the sense, during the evidence, with the availability of evidence, the red things which are highlighted are declared as a invalid causes. Here it is mainly due to maintenance. During maintenance, emergency stopper was bypassed, push button was not working, and all these yellow are qualifying cause. Clear? Any doubts? You understand how to apply, because selection of methodology purely depends on investigating team as well as the severity of the incident. For machines like EOT crane, small things, this sort of methodologies are very much clear. It will be very handy, it will be applicable, very simple for equipments, machineries, failures. If at all there are some disasters, will you be able to do with this? It require lot of inputs. So you require lot of statements, you require lot of evidences. You need to collect all the evidences from workplace, from the people, and you have to go back to the history, and you need to found from the log also lot of information. Then only you can able to conclude. Okay, next methodology is going to be 5 methods. What is 5 method? It is one of the simplest tool. You have to question people, you have to question, and you try to get a logical answers for that. So each and every answer you need to again further evaluate using why, until you get the basic cause. You need to use whys. It not necessary you need to complete 5 whys 5 times. Whys in 5 times. It can be 7, 8, 10 or whatever it is. Until you get basic causes, you need to put the question back. One of the simplest method is easy to complete without statistical analysis, can be used when problems involve human factors or interactions. Whenever there is a human is involved, this method will be very handy. The 5 whys typically refers to the practice of asking 5 times why the failure has occurred in order to get the root cause. Why this happened, why there is a fatality, why there is a head injury. The first case which we used faulty. Same thing here you can apply why. Why there was a head injury? What will be your answer? Why there was a head injury? Breakage of wheel. Why there is a breakage of wheel?
Speed was more.
Probably the speed was more. Why the speed was more? Operator did not check. You understand? So that's a way we can develop some logical answers. So that has to lead to the basic cause. Okay. With that I will stop now. In another 5 minutes we will try to continue with the case history. This